My name is Tejashwi and I am going to present about software architecture design process. Now, what is architecture design process? It is the process of planning the high-level structure and organization of a system, software system, focusing on components, their interactions, and overall system behavior to achieve some specific goal. It is important because it aligns business goals with technical implementation and constraints. It also ensures non-functional requirements like scalability, security, and maintainability. It is the key purpose its key purpose is to prioritize non-functional requirements, as we previously said. Now we are going to discuss about key component in design process, which is ADD. It stands for Attribute Driven Design, a systematic method for designing software architectures that focuses on fulfilling quality attribute requirements. Now, why ADD is used? Why ADD is key component in design process, architectural design process, because it avoids ad hoc decision making. It enhances efficiency, flexibility, and adaptability. It also provides a structured approach to make architectural decisions. ADD, it is an iterative approach and it also ensures whether the final architectures meet both functional and non-functional requirements by prioritizing the quality attributes like performance, security, scalability, and modifiability. Key concepts are iterative. It is an iterative process. Means the system can be iterated many number of times based on the user's requirements. By changing the user requirements, the system can be iterated until user um, the user gets the required system, and it is quality attribute focused and it is scenario based approach. The key steps in ADD process. The main steps in the ADD process are firstly to identify the architectural drivers involved in it, and to select the architectural tactics and their patterns, and we will decompose the system into components, and we will assign responsibilities for each components, and at last we will evaluate the architecture whether it meets the final output or not. The key constraints of these can be budget, technology stack, and the key functional requirement of this is the system should support core features of this. And now we will discuss about architectural patterns used in ADD. And we'll talk about a layered architecture, which is mainly used in ADD. There are three tiers. In first tier, there is an user interface. In second tier, there is presentation, application, domain model, and persistence. Coming to application, there are in application it includes apps, controllers, app services, event listeners. In model, it includes all the entities, collections, value objects, domain services, domain events. In third tier, there is data. It is an database server, search server. It also includes APIs. Uh, Layered architecture, it organizes the software into multiple layers where each layer has a specific responsibility, and it is commonly used in web applications with distinct presentations, business logic, and layers. And it is mainly used in enterprise applications. Its key characteristics are it is easy for maintenance and it is also easy for testing. It is reusable and modular, and it is for example it is used in banking systems with UI services and database layers. Now coming to monolithic architecture, it is a single tiered software application where all components are combined into one code base. Here it is used in small applications where there are limited functionalities, like it is used in startups, e-commerce applications, and MVPs, minimum viable product. It is used in e-commerce applications, uh, way and database operations in that exist in single project. It is very simple to deploy, and it is difficult to scale horizontally, and it is centralized code base. Now we'll move to microservices architecture. It is an architectural style that structures an application as a collection of small, loosely coupled services. It is mainly used in large, scalable, distributed applications and cloud-based applications. It is used in large applications like Netflix, Amazon, and Uber. Uh, this microservice architecture is used in this type of applications. It manages different services independently, like it manages payment, notification, and user management uh, services independently. Here, it uses APIs for communication, and it is independent for deployment and scaling. Here, each has its own database, and they can deploy independently without depending on other components. Now we will move to preliminary documentation. It is an important part in the ADD where it captures all the details about the project before it fully develop it full development begins. It contains all the details of the project, like it contains project scope and objectives, problem definitions, stakeholder requirements, and in the assumptions and constraints, and the budget informations, risk assessments and mitigation strategies, and stakeholder requirements, and high level architectures. And now we'll move to the tools which are used in the documentations. Mainly we use UML diagrams to document the system. For example, we use class diagrams, sequence diagrams to represent and visualize the system structure. We also use flowcharts, data flow diagrams. Flowchart shows how process flows, and data flow diagram shows the data movements. And we also use wiki-based platforms, version control systems like GitHub. In data flow documentations, it shows how data moves between system components by ensuring the consistency and integrity. The key components of these are sources and destinations, data processing, flow paths, security considerations. In sources and destinations, it defines about input and output points. In security considerations, it includes about the who can access the data. It and the information about encryption. And in data processing, it includes the steps for transformation or storage. In flow paths, it shows the interaction between components, how it will interact. Now we will move to the advantages of ADD. ADD, it mainly improves the communication between developers, architects, and stakeholders. It enhances the collaboration, and it is systematic design process. It ensures structured architecture development. It balances both functional and non-functional requirements, which helps make informed trade-offs. It is scalable and maintainable, and it is also iterative process which supports different quality attributes. Uh, it gives more ADD gives more preference to the scenarios because it defines real world scenarios based on quality attributes. It prioritizes scenarios based on business impacts, and it also uses scenarios to validate the architectural decisions. And finally, ADD ensures the software architectures, whether it is scalable, whether it meets all non-functional requirements or not. It also bridges the gap between business goals and technical designs by enabling proof systems that adapt to changing needs. And it is iterative process, as we previously said. It keeps on iterating until we achieve the required system. By implementing ADD, we can create and structured, maintainable software solutions. Its systematic approach leads to robust designs that aligns business objectives while ensuring long-term adaptability and flexibility. Thank you.